All right, so today we're going to talk about waves. This is lesson 2, types of waves. We're going to take some notes and think about it and do a couple of drawings. You should have already done your bell ringer and the attendance. Here is the first set of words or picture that we're going to look at with this lesson. So probably you know what a wave is. You probably know what an ocean wave is, or you've seen a sound wave. You might think of a wave more like these pictures down here. It goes up and down, up and down. How many of you have done the wave in a group of people? Surely not in the last year, but yeah. Okay, so we know that a wave kind of has high points and has very low points. It goes up and down. But these words here are going to be really critical. So I'm going to pull up my notebook and we'll get started with some notes to make sure. I'm going to label it waves 2, parts of a wave. Maybe I will. There it is. Parts of a wave. So let's try to look at this picture and our notebook at the same time. All right. So of course we're going to draw this wave, right? One of the important parts about a wave is that it's pretty evenly drawn. So let's go ahead and draw our picture. We'll go up and down. I know mine's not terribly even, but this is science, not art, right? Okay. I'm going to get out a couple of colors to help us kind of differentiate what we're looking at here. And we're basically just doing exactly what's on the screen. The crest is the high point. So this is a crest right here. This is a crest right here. Right. If you look at that, it should be, anyway, that they are all the crests are the same distance from that midpoint. Okay. So if the crest is the top, what word do we use for the bottom? Say trough. Okay. So every bottom is the trough. Every bottom. Okay. Now there's a couple of words that I do not want you to get mixed up, so we're going to point them out pretty clearly, and we're going to write a definition for these next words. Okay, so from the midpoint to the trough is called amplitude. Okay, from the crest to the midpoint is called amplitude. So I'm going to put an A here. Then we are going to define that word right here. Amplitude is the distance from either the crest or the trough you could also, kind of Bullwinkle moment, or the furthest point from the midline. So if this is our midline right here, so we could probably go ahead and label that. If that is our midline, then the furthest point away from it is either the trough or the crest. Right. Okay, now a lot of times people get the amplitude and the wavelength mixed up. So let's talk about wavelength. Okay. So from one crest to another crest, that distance is wavelength. From one trough to another trough, that is wavelength. The wavelength should always be the same. Now, could you have other wavelengths? Yeah, you could. But it would have to be from the same point on the wave to the same point on the wave. So if I wanted to start my wavelength right here, it goes to a trough, to a crest, and back to the same spot. That would be a wavelength too. Okay. It has to be the same spot on the wave. So let's define that. Wavelength. Again, it is a distance or Bullwinkle from the same point, from matching, we'll say. Wavelength tells us something about that wave too. Wavelength, we have different wavelengths of light. We have different wavelengths of different kinds of energy that we interact with on a regular basis. Okay. All right, so there's one more word that I can't show you on a still picture. Okay. So frequency has to do, let's write the definition of frequency. It says waves passing a given point per second. But we could just write it a little simpler by saying how many waves pass in 1 second. So frequency has to do with speed. How many times this wavelength goes by. Okay. We'll show that in the video that we watch here in a second. But frequency has to do with speed. How often is it? So we might even add that to our notes so we can have some recollection of that being said. Refers to the speed of the wave. Okay. Okay. We are going to give a unit to frequency as well. Okay. What unit do you notice in frequency? Second is a unit of time, right? So hertz, doesn't it? That's not funny, I know. But hertz, Hz, okay? This is a unit. And this equals per second. It also is the same as saying like waves per second, waves over second. Okay. So we're going to deal with this unit when we start to do some calculations with waves, but we want to be mindful that hertz is a unit of frequency. You probably have talked about hertz when you talk about speakers or when you talk about some other things. Okay, you probably heard that word before. All right. So, talking about frequency, high frequency versus low frequency. What's the difference? When you look at the picture, are there more waves on high frequency in the same amount of time? Because when we look at this graph, this gray line here, the midpoint is time. So as time keeps marching on, there's more waves in a high frequency wave than there is in a low frequency wave. Okay, so we'll go ahead back to our notes and take a note of that. High frequency is faster. Okay, or more waves per second. Think about like speed again, speed of a car. If I go 10 miles an hour, I'm pretty slow. If I go 55 miles per hour, which is per a time, it's a little faster. So a high frequency is faster, it's moving faster. And we'll just be really clear, low frequency is slower or fewer waves per second. All right, let's kind of look at what else we have to think about. Longitudinal versus transverse waves. Let's think. Just look at the picture for a second. Just look at the picture for a second. What do you notice is different? Right, longitudinal is just like lines. All right, if we think about the longitudinal and transverse waves, we're thinking about what is moving. Something is moving in with these waves. So a longitudinal wave, let's go back our camera. That's over here. Hold on. All right, so let's pull back our camera and we'll talk about the longitudinal wave for a second. If this is our material, okay, we're going to talk about a slinky. Way more fun if we could actually do this, but can't share things. This is the action of a longitudinal wave. Okay, what do you notice? The pieces of the slinky smash into one another and then recoil. So if you notice the lines are tighter together, that's where they're smashing. And then when they're spread apart, that's when they sort of unsmash. So that is the action of a longitudinal wave. Okay. These are also called compressional waves. So we'll write that down here in a second. But compressional, it presses together. Okay. Notice they hit each other. So let's write that down. Okay. Longitudinal equals compressional. Compressions. Okay. So this is the way sound waves work, and we're going to talk about that a lot more in depth in a little while, but sound waves crash into the air in front of it. So the wave in front. An example is sound. I can't, we might not do this video. The example is sound. Okay. So let's look at the other kind of wave. The transverse wave. So let's, transverse waves are, an example would be light. Okay. So notice the particles actually move up and down. Okay. So let's look at that with the slinky, our tool. We still have material, but if this is compressional, this is longitudinal, then our transverse wave actually moves like this. So that material is actually moving in a wave pattern. Okay. So transverse equals up and down movement. So an example would be light. Okay. All right, so that's going to be all that we need to put in our notebook. We're going to go ahead and watch the video here in the lesson and then do the exit ticket questions.